Hi, I'm going to talk about 2017 second FRQ for AP Chemistry. And for part A, it asks you about the formal charge. So, what is formal charge? Formal charge of an atom in a molecule is the difference between the number of valence electrons on the free atom and the number of valence electrons assigned to the atom in the molecule. And there's an equation for that. The number of valence electrons minus 1/2 shared electrons minus the lone electrons. For H, the valence electron is 1, for C is 4, for N is 5, and for O is 6. Same on this side. So let's use the equation and put numbers in. Let's do HCNO first. So H is 1 minus 1/2 2 because it shares 2 electrons over here, and minus 0 because it has no lone electrons, and it's equals to 1 minus 1 and it equals to 0. So for C, it's 4 minus 1/2 8 because it shares 6 here and 2 here, so it's 8, and minus 0 because it has no lone electrons, equals to 4 minus 4, which is 0. Same for N and O. It's 5 minus 1/2 8 minus 0 equals to 1. And 6 minus 1/2 2 minus 6 equals to -1. So this is the formal charge for this part, and for the other part it's same atoms, and for H it's 1 minus 1/2 2 minus 0 is equals to 0. For C it's -1, for N it's 1, and for O it's 0. So after we done all this, you can see there's no big difference between this and this. So there's another definition for formal charge. It's more electronegative atom should have the most negative formal charge. So in this case, O is the most electronegative atom, so it should have the most negative formal charge. So in this case, it has -1, and in this case it has 0. So compared to those two, the left one is better. In order to get a full credit, you need the calculation process, and you have to know, since O is the most electronegative atom, it should has the most negative formal charge. So one for here, one for here, you get 2 points. So let's do B part. For B, it's asked about the delta H, the value of delta H. So in this graph, it gives us the enthalpy of the bonds, so we just have to plug that in. For HCNO, we know H bond with C is 413 plus 891, because this from here, and plus NO bond, which is 201, and we got 1505. And for the other one, HNCO, HN bond is 391. NC bond is 615, and this is 745. So this is 1751 kilojoule per mole. So we should know another concept right now. Enthalpy is endothermic. All bond enthalpy are endothermic, which means it takes energy to break the bonds. So in this case, we have to break HCNO to form HNCO. So 1505 so the enthalpy for HCNO is positive and the other one is negative. So it's 1505 minus 1751. So it's negative 26. So it's negative 246 kilojoule per mole. And this is the answer. So for this question, this is a 2-point question. In order to earn both 2 points, you have to understand the concept and you have to get the right answer. So it's 1 for concept and 1 for the value. So yeah, 1 for 246 and 1 for the process. So C asked about the delta S. We know that the definition for delta S is the delta S is related to the phase change or the number of moles of gas changes. So there's no phase change in the previous reaction because it's from, let me rewrite that, HCNO to HNCO. So both of the phase for this one is gas. So there's no phase change. And the most of gas change is 0 because it's 1-to-1 ratio. Therefore, the delta S is close to 0 because there's no phase change and the number of moles is the same. So for D, there are 2 words in this question you have to understand. The thermodynamic favorability is delta G, and the equilibrium constant is K. So this question is asking for a higher concentration in terms of delta G and K. So there's equation for delta G. Delta G equals to delta H minus T delta S. And in this case, from the previous questions, we know delta H is negative 246 and delta S is close to 0, so those is 0. And therefore, we know delta G equals to delta H equals to negative 246 kilojoule per mole. So because of delta G is negative, we know that this is the product favored reaction. So in this case, the product is HNCO. So HNCO has a higher concentration. And there's a concept we have to know. When delta G is negative, K is bigger than 1. And the reason why K is bigger than 1 is because the equation for K is K, the concentration of product over concentration of reactant. So when the product is greater than the reactant, it has to be bigger than 1. So here it is. In terms of K and delta G, the HNCO has a higher concentration. So this is the 2-point question. For 1 point, you have to know the value for delta G. And the other point you earned for the connections between K and delta G. So yeah, that's it. So E has 2 parts. So the first one asks you to support the student's proposed rate law. So from the rate law that is being given, we know this is the first order reaction. Because of the power it has, it doesn't have a 2 or 0 above it. So this is the first order reaction. And there's the special thing about the first order reaction is it has a constant half-life. So in this case, we can tell from 0 to 10, it decreased by half. It's from 0.1 to 0.05. And from 10 to 20, it goes from 0.05 to 0.025. And from 20 to 30, it's from 0.025 to 0.0125. So the relationship between them make them fit the condition of the first order reaction. That's all you need to say about the first part. For the second part, it's asked about the volume. So there's an equation from the equation sheet. It's the half-life equals to 0.693 over k. So since we are looking for k equals to 0.693 over half-life. And it's equals to 0.693 over 10 because we know the half-life is 10 from the table. And therefore, k equals to 0.069. And don't forget about the unit. Since the unit for half-life is hour, so it's 1 over hour. And that's the answer. After you've done this, you get the 1 point. So for F, it's asking you about to create an experiment that can determine whether the rate of the reaction depends on the concentration of OH minus or not. So in this case, it tells you the pH for this reaction is 13 right now. So in order to change the OH minus, you can just simply lower the pH, which means decrease the OH minus and keep everything else the same. So you can get the difference between them if the OH changes. So for this one, you can just lower the pH and keep everything else the same, because you change the pH is change the OH minus, the concentration of the OH minus. You decrease the OH minus. So if you do this, I think you answer the question. And that's all you need to do for F to earn the 1 point. That's pretty much it. So thanks for watching.